So once again, ladies and gentlemen, you're all welcome. We've looked at the two kinds of distribution, the binomial distribution, the Poisson distribution. We have seen clearly the differences. And one of the major differences is that the Poisson deals with the mean or the average over a certain interval, whether it's a time interval, whether it's a space interval, or a length interval. We've seen that. Whilst a binomial is just Bernoulli, okay? You just identify that this thing is in two parts, and then you looked at it. But you see, life is not all discrete. Practically, the outcome of many random variables can be continuous, can have decimals. And this is why we need to study the probability distributions of continuous variables, not just discrete variables. So there are so many things that are continuous. Can you type for me an example of any distribution, any kind of data set that is continuous? I'll give you one example. The height of people is normally distributed. Okay? The height of people is normally distributed. It's also continuous variable. Okay? So the height, the age, the weight. Good. Precious just mentioned the age. So there are quite a number of these. And we need the Gaussian distribution to handle these things. It was discovered by the German mathematician Carl Friedrich Gauss in the 18th and 19th century. This man lived, and he developed what we know as the Gaussian distribution. I'm going to show you something. Okay. Now I'm going to show you a typical example of what I mean by this Gaussian distribution. So let's assume we have something like this. Okay. Let's assume we have something like that. And then we have something also like that. I'm going to just draw a random variable. So this is a random variable that I'm going to just demonstrate it. So let's call this random variable X. Okay. Let's call this random variable X. This random variable, you need to assume that is normally distributed. So it could be the ages of people. And the distribution goes this way. It's not nice. Sometimes when you're drawing the distribution, you want it to be a bit nicer. And this distribution will have the center of attraction, the central tendency. And so that becomes what is known as the mean, the center. Now, for this distribution, what is interesting is that half of it is indicating the center. One side is half and the other side is half. The entire space is known as the area of the distribution. The entire space is the area of the distribution. Now, this whole area is 100%. The whole of the area, okay, the whole of this area is 100%, or the probability is equal to 1. Now, the essence of our job is to find out that if I should give you some portions of the area, can you tell me the other portions of the area? For example, let's assume that this portion here, okay, that I've colored, let's say this portion that I have here, okay, I have given you that portion. If I have given you this portion, the question is that, how will you be able to tell me the other portion that I have not given you? How will you be able to tell me the other portion? That is the first essence of the normal distribution. So remember, the mean is the center, and the standard deviation represented by sigma is just below the mean. How spread it is from the center is a standard deviation. And we are going to learn. And remember, one of the things we said about any distribution is that first, you need to know the formula for the distribution. Second, you need to know the mean. And finally, you need to know the standard deviation. Okay. So the normal distribution is very practical, very, very practical. Now, the shape of the distribution is the normal curve, which we have just shown here. So in this normal curve, you have, and I love that, okay, because the beauty of this thing is this. You have the mean in the middle, okay, you have the mean in the middle. Then the area, half of this area is the 50% and the other half is a 50%. Now, ladies and gentlemen, what I'm most interested in is this. If you want to move to any part of the area, you need to start from the mean. So when you start from the mean and you are going to the right side, you start from the center towards the right. So the movement, whenever you are moving, the movement is in a format like that, okay? You move in this format. Anytime you are moving, you move. And when you're moving to the left, so you move from the center to the left. That is how you do the movement. So the movement is always done from the center to the right or from the center to the left. Okay, so keep that in mind. That is an important first step. Okay. The second thing is this. It is a fact that there can be different kinds of standard deviation and different kinds of mean that will change the shape of this distribution. Different standard deviation, different mean that will change the shape. So, as an example, if you look at this, okay, if you look at this, now, if you check here, this point is 0 in terms of deviation or the standard deviation. But if you look at the peak is so high up there, okay? The peak that you are having, it is so high up there. And so we need to be able to know whether there are different peaks in there. I'll give you an example. Let me see if I can just follow you an example here. The deviation from the center is a skewness, okay, which is telling you how flat or wide it is. And I'm going to give you different means with different skewness so that you can appreciate this. The area under the normal curve, I've told you, is measured by determining the number of the deviations the value of the random variable is from the mean, okay? Now, so this is a point, and I just want to kill this and then go back to my graph. We want to know the area under this curve. And to be able to get the area under this curve, we need to be able to know the number of deviations from this center. We need to know the number of deviations from the center. But how do you get the area? This is a random variable x. How do you get the area? Well, you have this random variable x. To get the area, you need something to help you. And that something will give you the area. By the way, the area is known as what? The probability. So the area is known as the probability, P. Now, there is already something that has been established before you and I were born that can help you to be able to move from this standard random variable in order to get the area that the random variable captures. And that is known as the standard normal Z table. So for a standard normal variable, the area under the normal curve has already been computed and there are available tables to do that. The formula that will convert the normal random variable, which will have a mean and a standard deviation, and I will convert it to the normal standard random Z. This formula will do that trick. So I want you to write this formula down. This is a key formula down, okay, because this is a formula we'll be using to convert a particular random variable X and gain the area it is covering or be able to detect the probability of that particular random variable occurring. Okay, so look at some examples that we have here. I have all my charts here. Okay, so when you look at the first one and you look at the mean there, the mean is 100, the standard deviation is 10. All right, you got a mean of 100, the standard deviation of 10. Now look at the peak. The peak is a bit flat. Now, if you compare the standard deviation of 10 with the standard deviation on the one on the right, if you look at the standard deviation of the one on the right, you will notice clearly, let me just see if I can capture that idea. You will notice clearly here, okay? You will notice that the peak is so high. You have a very high peak there because the standard deviation is lower. So the lower the standard deviation, the closer the peak, the higher the peak that you're going to have. So you can see that this one exhibits a higher peak than the one with a higher standard deviation. But if the standard deviation is so high, like 15 here, even though they're all having the same mean, the bell shape is flatter, as you can see in this last one. And so changing the standard deviation and or the mean, as for the mean, it will just shift it from the center. For example, if you look at the last one at the bottom left here, 130 mean is gone up. So the mean is shifted from 100 to the new center of 130. Why are these important? Well, they are important. Why are they not important? They are important because if you look at the way the mean is, it will help you to know. If you look at the way the peak, the standard deviation and the mean is, it will help you to know the exact peak that you are dealing with. Now, the most important thing here is your ability to be able to determine the area under the curve. The area under the curve. So if you look at this area here, let's assume that we want to find this shaded area. What the first thing you want to do is to realize that to get this area, the half of this is already 50%. So there's nothing you will do that you just pick that number 50%. But how many percent is this area? What is the probability of this area? Well, what you want to do is to calculate the distance from the center, and I mean it, the center to that point, that ending point that you want to actually deal with. So it has to be from the center to that ending point, okay? That point, how do you get it? Well, you know the value of the B, okay? So the value of the B is here. So you know this value, so you pick this value, and then this value, you are now going to calculate the value, noting that you are moving from the center to the value. You will use the Z approximated formula to do that. Once you have the Z approximated formula, you read the value, the probability. You read the probability on the table, and then that will give you the space here. So you now add this one to the already 0.5, and that will tell you the whole space. What about this space? How do you get this very space? Okay. Now, finding this space, okay, is easy, but not that simple. First of all, you don't need this space because that's not a space that we have this point on, the probability of this variable. Secondly, you need this space. You need this white space, which I'm now shading it as kind of yellow. You need this space. Why do you need this space? You need it because there is no way you can travel to this green area unless you have crossed this kind of recent, I just shaded this place, okay? You have to cross it because you always start the reading from the center. So you will calculate this probability using the Z approximation. You will calculate this probability. Once you've calculated the probability, you know the whole space is 50%. So you now subtract that from 0.5, and that will give you the space that you are interested in. That's it. Now this last one, okay, to get the area shaded, you just need to find the probability for the center to the A, okay? Then you find the probability from the center to this B, and then what do? You add them. You add them, okay? But if it was the white space outside of it, you need to find the probability from the center to A and from center to B. Then you subtract these answers from 0.5, and then you can now find the spaces outside, which are these spaces outside. We're going to take a couple of examples to be able to really get it. So let's start with this example. Okay, let's start with this example. I like this example because it just shows clearly what is really happening. Now, in this example, let me clear this first. In this example, you have some income of Kaya U sellers. Okay, you have the income of some Kaya U sellers there. Now, when you look at these income, according to the rule, it's normally distributed. So this is not where you have to think whether it's normally distributed or not. It's already normally distributed. And every time you'll be notified. With a mean of 100 cedis and a standard deviation of 50 cedis. Given this, what is the probability that if I go to Accra right now and select a particular Kayayo, what is the probability? What are the chances? What is the likelihood that that person is going to be earning 200 Ghana cedis more than the mean of the 100 cedis? What is the probability? Ladies and gentlemen, the first thing you always want to do with questions like this is to draw. Draw, because when you get used to that drawing, half of the work is done, because drawing gives you a better understanding of what is happening. So I'm going to draw here. So you can watch me and try to follow me in yours. So I'm going to have this as a first kind of drawing. Okay, have the second one as a second kind of drawing. And then I'm now going to draw the normal distribution. Okay. I'm going to draw the normal distribution here. All right. So in this normal distribution, I'm supposed to identify the mean in the middle. So I'm going to identify the mean in the middle here. This is a mean. And according to the question, the mean was given as what? 100, and the standard deviation was given as 150. So down here, you write mu, which is the mean, and then write 100. And just below it, you write the standard deviation, and then write 50. Now, you have been told that a Kayayo is going to be selected at random. What is the probability that that person will be earning 200? 200, you always have to ask yourself, is it to the right of the mean or to the left of the mean? So tell me, guys, is it to the right or to the left, the 200? Is it to the right of the mean or to the left of the mean? It is to the right. Once you identify that it's to the right, you indicate that 200 and then write the name, the number 200 there. So if you identify that. Now, you need to shade the area you are interested in. Now, to do that, you need to go back to the question, because the question was very clear that what is the probability? What is the probability that a Kayayo will earn income of 200 cedis? Now, remember, I didn't say will earn an income of less than 200 cedis or will earn an income of more than 200 cedis. But it says an income of 200 cedis. Now, that's a very important word. Now, why is this important? This is why it's important. It is important because, and let's go back to our graph. When you go to the graph, if it had been an income of more than 200 cedis, then we are talking about the space above here, okay? We're talking about the spaces here. But if it was an income of less than 200, then again, we're going to go talk about all of this space here, okay? That's it. But this time, he didn't say that. He said it should be an income of 200 cedis. So it's just from the center to where the 200 is. So the area in question that we have to just shade, that area that we are interested in is the space. So we are talking about the spaces here, okay? These are the spaces in question that we are looking for. So we are looking for this area here. We need to find this area. Okay. And how do you get that? This is why you use a Z approximation. How do you do that? Well, to do the Z approximation, because now we know this is a random variable X, so Z formula will be written. Okay. Let me use a different one to just make it much more poignant. So you write Z equal to X minus mu over sigma. This is a Z approximation. So what is going to happen is that we are converting this X to a Z, and then we use a Z to help us to find the probability, which is the area that we are looking for. Fitting the values that was given to you. The values were X. X is 200. Mu is 100. Standard deviation is 50. Therefore, our Z is what? 2. Always make it 2 decimals, so 2.00. So now we know our Z value. Remember, the X will help us to get the Z will help us to get the probability. So now that we have the Z, we need to go and read it on the Z table. The one that I said that it was created before you and I were born already. So we know the standard approximation of this. So I'm going to just pick on that, and then we find the actual, value for the Z. So I posted this also in the group page. So please take yours and follow me as I search for this Z. So let me first show you the table. This is the Z table. And in this Z table, you can see, let me zoom it slightly. Okay. You can see that on the far left column are the Z values. And then the continuation are on the top right. And it's because of this top right that I say your answer should always be in 2 decimals. Because if your answers are in 2 decimals, it will help you to be able to follow through. Now we are looking for 2.00. So 2 will be looked for on this far left section. Obviously, since these are 1, we need to go down until we get to 2. So this is 2.0. Now we are looking for 2.00. Right after this, the next column is 0. The next one is 1. The next one is 2. So 2.00 will be here in that next column. Okay. So you can see clearly from here, you can see that I have my 00 there. So when you scroll down, and then it matches Z2, you will pick the actual value of Z, the actual probability value. So 2.00's Z value corresponds to a probability of 0.4772. Okay. That is the value of 0.4772. That's it here. If you can see it, that is the right value. I'm sure you guys can get it. So now that you know the value, you now come back to your computation. And in this computation, now that we know, so we know this area now. So the area is what? The area is 0.4772. In percentages, that means that we are talking about 47.72%. Okay. So how do you now write it? Because how you write it is also important. So you're now going to say the probability that X is equal to 200 is equal to the probability that Z is equal to, and we found the Z to be 2.00. And this is equal to 0.4772. That's it. We didn't do any subtraction. We didn't do anything. It was a direct movement from the center to the 200. Okay. And it's an equal to symbol. So that is how. So what does this mean? Now you've got the answer, but what does it mean? It got to mean something practical. And it does. It does. What it means is that if I should go to that market to look for a Kayayo, the probability of getting a Kayayo who is earning 200 Ghana cedis is not easy to find such a person. Okay, the probability is not even up to 50%. You are going to have 47.72% chance of finding such a person who is earning 200, because the mean is 100. The mean, the average is 100. So a lot of people are getting 100. So to get somebody who is making 200 Ghana cedis, your chances are a bit slim. It's not even up to 50% chance. And that is a point being explained here. So when you go to the slides, I have executed all of these there, and you can see the answers for that. So this is it. Okay, so the conclusion here is that there is a 47.72% chance that a Kayayo will even earn 200 cedis. This is how you execute it. Now let's go to the next one. Okay, next example. And in this next example, I'm going to work on just two of them. Then yours is to have the ability to draw. Because if you can draw it, you can calculate it. Bogas, this is another example. Bogas sells furniture and carpets from 2 sales record. Management has found that the mean number of yards of a carpet demanded by customers during a week is 4,200 yards with a standard deviation of 1,400 yards. The question you are being asked is a very simple question. The store manager wants to know the probability of, the probability that a particular carpet demand in the upcoming week will exceed 6,000. Now, remember, I said that you want to know whether the carpet is going to exceed 6,000. It didn't say carpet will be 6,000. No, it says will exceed 8,000. It didn't say carpet will be below 6,000. No, it says will exceed 6,000. So how do you do that drawing? It's a very simple thing. How do you do that drawing? Okay. Now, let me quickly show you how you do that drawing. And I'm going to work it out with you. Because sometimes when I show you the drawing, it's very easy, but I wouldn't want to show you the drawing. I rather want us all to draw it together. So the first thing you want to do is to showcase your drawing. So you draw a y-axis, and then you draw your x-axis. Okay. Once you've done that, the next thing you want to draw is your normal distribution curve. So you're going to draw the normal distribution curve. And then you showcase the center of the distribution. You showcase the center of the distribution. So let me just indicate this center of the distribution. Then you have to, of course, indicate the mean. Okay, the mean is there, so you need to indicate the mean. So you write mu equal to, the mean was 4,200. The standard deviation, you indicate that that one is 1,400. And you were told that there is 6,000. The manager want to know whether a particular carpet, will exceed 6,000. So 6,000, you ask yourself, is it to the right or to the left of the mean? Obviously, it's to the right of the mean. So you indicate that and then write your 6,000 random variable. And then you shade the area in question. You shade the area in question. Now go to the question. It says the area in question is anything that exceeds 6,000. So you just need to shade the area that exceeds 6,000. So we are talking about this area, okay? This area. That is the area that exceeds 6,000. That is the area that we are looking for. Now, to be able to get that area, you and I will both know that we first need to cross this barrier. Okay, we need to know this barrier. So we need to know the probability of x equal to 6,000. Once we get that answer, we'll subtract that answer from 0.5, because remember the whole area here is 50%. So you subtract that from 0.5, that would then give you this little area that you are looking for. Okay, so let's do that. So you need to find the z for that. So the z is going to be x minus mu over sigma. Now, X is the random variable, which is 6,000. So 6,000 minus mu, which is 4,002, divided by the standard deviation, which is 1,400. Work it out, and you should get something like 1.29 standard deviation. So this means that the value you're looking for is 1.29 standard deviation away from the mean. That is what it means. Now, how do you read this? You go to your table. Okay, so let's go to the table. We are looking for 1.2 under 9. That's how you do it. Because remember, it's 1.29. So here we look for 1.0, 1.1, 1.2. So we're not at 1.2. Okay. Now under 9, 1.2 under 9. Remember, this is 0. So the last one is a 9. Okay. So let me just switch this one here. Okay. So this is it. The last one is the 9. So if I were to track it slightly, if I were to track it slightly, I'm talking about this one, okay, going all the way, going all the way, going all the way to that. So you can now see clearly the beauty of let me just capture that guy that we are looking for. This is a guy we are looking for. This guy. That's it. That's a value that we are looking for, 0.4015. Now, how do I know that this is an important? Because that is a 9. If you scroll up, you see that that's a 9. Okay. See, the 9 is right there in that upper layer. And so 0.4529, this is the value that we are looking for. Now that you've gotten that value, let's go back to our table. So we can now say that, now you have to write it. Probability of X equal to, sorry, now we are talking about X greater than 16. So you have to now do greater than 6,000. Okay, is going to be a probability of Z greater than 1.29. And this will be equal to, now you have to subtract a 0.5. So you have to add 0.5 minus the one you had, 0.4015. And when you do that, what do you get? 0.08. What do you get? You should get some value related to that. Okay. 0.0898. Okay. Yeah, 0.0. Let me just go back. 0.0985. Very good. Somebody just. Okay. So in percentage, that is approximately 9.85%. Fantastic. So what does this mean? So it means that if you are expecting, since the average is 4,200, okay, if that is the average and you are looking for the fact that a particular selected carpet at random is going to exceed 6,000, really? Like the whole area is 4,200 and you want something that is 1,600 more? Your chances of getting any carpet, which is 6,000 or more, is slim. It's just under 10% because the average is even 4,200. Because 6,000 or more means you are talking about thousands and millions. So the chances are very slim. Very, very slim. Good. Now that you understand this, can you now draw? Because your ability to be able to indicate the drawing is important, because at the end of the day, the most important thing is your ability to draw. So let me take you back to the question. Show me how you can work out these ones. Okay. This top one, let's start with it. What is the probability that demand for carpet will be 5,000 or less? 5,000 or less. How would you draw that? You can raise your hand if you think you can guess how to draw that. Okay. How do we shade the area 5,000 or less? Who can do that? 5,000 or less. Because your sharp mind in its ability to indicate the area is most important. Stephen. Stephen wants to try, so let me just unmute you, Stephen, then you can try for us.
Okay, Doc, thank you. So the 5,000 will be on the right side of the 4,200, but it will be shaded all over to the left, beyond even the mean the mean line.
So to be, you said it to be on the right side, right?
Yes, please.
Okay, so this is the mean. So 5,000 will be on the right side.
Yes,
And
and we shade to the left, beyond even the mean line, shaded towards the left.
So all of this area, let me just use a spotlight. Okay, so you are talking about everything here, including this.
Yes.
Very good, very good, very good, very good. To be shaded all of this because of which word?
The less than.
Less than. That's it. That's it. So this becomes the area in question. If you go and shade this area, you are wrong, because this is the area question. Fantastic. That's how it's supposed to be. Okay. You see, once you know this, then how do you calculate it? Well, simple thing. All you do is calculate. Already we know that this one is 0.5, isn't it? So this section here, you don't calculate. It is already 0.5. So what you do is to just calculate, find the probability value of this here. And once you get that, add it to 0.5, and you are good to go. Fantastic. Now let's go to the next one. We're not going to work these things. What is the probability that demand for carpet will be between 3,000 and 5,000? Who can tell me how to draw that? What is the probability that demand will be between 3,000 and then 5,000? Mark Claire is going to try that for us. Yes, Mark.
Yes, sir. So for demand being between 3,000 to 5,000, you put the 3,000 on the, okay, so you're drawing. The 3,000 will go on the left side of the mean.
Left side of the mean, okay.
And the 5,000 will go on the right side of the mean.
On the right side of the mean,
And with the shaded area in between the 3,000 to 5,000.
So you are saying that if I want to shade, my mind should be centered in the arena, centered in the arena here, in between, everywhere here.
Yes, sir.
Okay, okay. So that's it, that's it. That's exactly what he's trying to say, that this is a section that we are looking for. All right, now how do we solve it? Can you guess quickly how we solve it? How do we solve it? Mark, I'm meeting you because you didn't finish. How do we solve it?
So you find the probability of 3,000 and you deduct from 0.5 on the other side, plus the probability of the 5,000 side, and you deduct from 0.5, but you add these two probabilities.
You add these two probabilities and then what? You add these two probabilities and what? Is that it? Because you said two different.
Okay. If you do it the way you have done it, then you deduct from one.
Okay, you don't have to deduct from one. Okay. Once you add them, that's it. You're done.
Okay.
Why is that so? Because the thing is this. Because the value you got for the 5,000, let me write 5,000 here. Okay. The value you got for the 5,000, okay, that value you got for the 5,000 is from the center here to the 5,000. And the value you got here for the 3,000 is from the center here to the 3,000. Okay. And then the question was very clear. It says that between the two of them. So the value you got, you already have it there. The value you already got there. So you don't need to do anything than to just add the value you got here, okay, to the value you got here. Isn't it?
Yes, sir.
That's it. And that's it. So that is how you do it. Okay. But if they were outside values you were looking for, if we were looking for, if the question that we had, if it was rather telling us to look for something here, okay, if we're to look for something here or something on the upper layer here, then we are going to subtract the answers we had, each one from 0.5 and each one from 0.5, and then we add those answers. All right. Let's go to the next question. Okay, the next question here. What is the probability that demand for carpet will be at least 2,000? At least 2,000. Who can walk us through how we should demonstrate that? At least 2,000. At least 2,000. Again, that one is very simple. So let me just take you to that section. Okay, at least 2,000. This is 6,000. Okay, I think I didn't even do that one because that one is so simple. One is usually so simple. That's what happens. So let's do the last one. This is the last one. What is the probability that demand for carpet will lie between 3,000 and 5,000? I think we've done this. That's the one we did. So yeah, this is at least 2,000. So at least 2,000 means that we know that the mean is in the center. Okay, so 2,000 must be to the left of the mean and then everything above that. Okay, so 2,000 is to the left of the mean and then everything above that. So that one I wouldn't do. To the left of the mean, when you calculate, you get a minus. Please know that whenever you get a minus, you just go and read the absolute value on the table. So in this case, on the table, you go and read 1.5, then you look under 7. Okay, 1.5. And let me just give you a clue of this, because this thing, sometimes if you don't have the clue of how you go about it. Okay. So when you have something like this, and then you draw that, this is the 4,200. At least 2,000. 2,000 is on the left. Okay. So we are talking about everything to the right of this 2,000. Everything to the right. Okay. Every situation that you are going to get here. That's what we are talking about. Okay. And at least 2,000 is that. So what you're going to do now is to calculate. So what you want to do is to calculate the 2,000, the probability of X being 2,000. Okay, you calculate that. Then you are now going to add that one to 0.5. Okay, so your final answer is going to be plus that one you calculate plus 0.5. So your value you get will be this one. Then you add this one to 0.5, and that will give you the final answer that you're looking for. So that was it. So this is a 0.5, and then you add it to the one you found. That gives you that. Let's go to the last one, which I want somebody to walk us through. What is the probability that demand for carpet will be above 2,000, but below 5,000? Who can walk us through that? Above 2,000, below 5,000. Above 2,000, below 5,000. Steven want to walk us through that? Okay.
Yes,
So,
Doc.
oh, yeah, go ahead. Let me just, yeah. Above 2,000 and then below 5,000. Above 2,000 and then below 5,000. Why is the meeting not working?
Okay, Doc.
Yeah.
All right, thank you. So I was saying that the 2,000 will be on the left of the mean, then the 5,000 will be on the right of the mean. Then the needed area will be the this space between the 2,000 and the 5,000.
Good. Good. I know
Thank
you
you.
said it similar to me before, so we are talking about the spaces here. Once you can shade and identify the space, the rest is history. Okay. So that is the whole idea. Now, this is how you execute when it comes to normal distribution. So by the way, when you check the notes, you see that is exactly what he has indicated. I'm now going to take you through a new approach to understand. Now, we've learned the skills of how you can move from X, okay, to Z. If you can remember, we've learned how you can move from X to get the Z value and how to move from the Z value to get the probability. Now we're going to go the other way around. That's how we're going to do it. We're going to go the other way around. So it's like, now if you have been given the probability, how would you have gone ahead? Now, first of all, understand that the Z value is equal to X minus the mu over the sigma. So I can make X the subject here because now we are moving from the P to the Z, from the Z to the X. So if I want to get the X, I just cross multiply, okay? I cross multiply the Z by the sigma so that I get Z sigma, okay, equal to X minus mu. And if you want to make X the subject, you take the mu there, and that will give you the answer that you have, which is right here. That will give you our superlative, somebody say, our big answer that you are seeing right here. So you're going to get this answer as the one that we are in charge of. But the question is this: so we have been given the P or the percentage or the area. How do we get to the next? Now, let's go and then take a practical example of how we do the movement. Okay. So here you have a question that says this. And again, this is tricky, so please pay attention. The question says, suppose that the price of wache, suppose that you have the price of wache here. And this price of wache is normally distributed with a mean of 8 cedis and a standard deviation of, 5 cedis. You have that there. What should the price be? Now he's asking you of the random variable. What should the price be? And that sentence is a very important. What should the price be so that only 20% of all prices are below this price? Only 20% of prices are below this price. So I don't want you to tell me a price, an X value, in such a way that only 20% of the prices are below this price. Okay. Now, let me take you to our whiteboard, and then I will demonstrate what we have been told and what we are looking for here. So when you look on this board here, let me just indicate our graphic. So you have something like this, and then you have something like that. Okay. And you have this normal distribution curve. And this normal distribution curve is exhibiting something interesting because you have been given the mean as well as the standard deviation. So this is the mean, and you have been told that the mean is 8 cedis. So I'll just write mu equals to 8. You have been told that the standard deviation is 5 cedis. So it means that sigma is equal to 5. And then you have been told that there is a price. And I want to take you back there because that you need to understand what you are being told. It says, what should the price be? So along that mean line, there's a price. What should that price be? That only 20% of all prices are below this price. Now, that word, only 20%. Let me just take you back to this section. When you are on this line, and I'm going to use an arrow to indicate the whole of the line I'm talking about. When you are all over this line, okay, all over this line, what is the percentage that you are dealing with? The whole of this line is dealing with how many percent? Okay, it's dealing with 100%. That's what it's dealing with. And so as you are moving, okay, if you pick it and you are moving, okay, you are moving. as you keep moving and moving, because somebody said, as you keep moving and moving and moving and moving and moving, okay, you are increasing the percentage. You're increasing the percentage. By the time you get to this section, boom, okay, the percentage has changed to what? 50%. That's it. By the time you get to the middle, it's changed to 50%. And as you keep going, it keeps going to 60%, 70%, and all of that. The question says that, what should the price be so that 20% of all prices are below this price? So I want a situation where, so these are all prices. These are all X's, okay? So along this line, you have X, 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 X throughout. So this is X. There is a price along this, and I want 20% of the prices to be below. Now, if I am here, 50% of the price, if I am at the mean, if I am at the mean, 50% of the prices are below the mean. Do you agree with that? Perfect. Now, if I am somewhere to the left of this mean, okay, let's assume that I'm somewhere to this section here, okay, it means that about 30% of the prices are below the price, this line price I've done. If I draw another line here, what it means, and I call that line, question mark. And I'm going to put a question mark here because I don't know what price this is. This is a certain price. I want a situation, 20% of the prices are to be below this price I just wrote. 20% of all prices are to be, did I say 20%? I don't know the price. There must be, 20% of the prices are below this number. I can say that, yes, 20% of the prices here are below this number. But what is this number? What is this price? The reason why I can say 20% is because on the left of this line that I've just drawn, on the left of this very line that I've drawn, I can deduce that left of it will be 20%, okay? And then this one will be 10%, then we have 40%, then 50% is the whole of the left side. So we are looking for this X variable here. We are looking for this X so that in such a way that 20% of the prices are below. So we are looking for this area. And this area, we know the area. We know the area because we were told that the area is what? 20%. So this is 20%. That is 0.2. Now listen, anytime before we get to this area, normally we move leftward, don't we? Every time before we get to this area, we normally will move leftward. So normally we'll move like this before we hit this area. So before we got a 20%, we must have gotten a certain number here. What number was that? What number was that? You can tell me. What number must we have gotten before getting to this 20% area leftward? What number did we cross first? 30%. Excellent. So this is 30%. So we know this area is also 30%. Okay. Now 30% is 0.3. So we need to find out 0.3. So what it means is that you need to go into the table. It's a probability. Don't forget, it's a probability. So we need to go into the table and search for the entire table for 0.3 or the number or the numbers closest to 0.3. So let's go to the table. This is the table. This is a table. And in this table, we are going to search the entire table looking for 0.3. That's what you're doing. Okay. You're going to search. You can see that 0.1, 0.2 are all in this area. 0.3 is somewhere there. Okay, let's go to the closest. Normally it will be 0.2 something, something, and then 0.3. Okay. The closest number will be this. The closest number will be the numbers that are closest to 0.3. Okay. The numbers that are closest to 0.3. And there wouldn't be any number closest to 0.3 except this number that you and I are seeing right here. Okay. So that's 0.2995 and then 0.3023. The question you got to ask yourself is that which of them is closest to 0.3? Who can tell me? Is it a 0.29 or the 0.30? Which one is closest to 0.3? Which one is closest to 0.3? Is a 0.299, okay? I got a very quick answer from Stephen. Why? Because, by the way, the only way, sometimes the clear way of finding it is just take 0.3 and subtract each one of this from it. The one that will give you the smaller absolute value is the one closest to 0.3. The one that will give you the, and if you look at this one here, the 0.2995, it is so close to 0.3. Because if you look at this, there's a kind of something like 23, if you make it 23 something, 0.00023, whereas this one is 0.005. Okay, so you need 0.005 to be able to get to 3 from the 2.99 than the 0.0023 before you get to the 3. So the closest number is what? Is point. So now you're not even making it just close by, it's not the closest now. 0.2995. Okay. Now that you've gotten that, what do? You now have to read its z value on the left and then its continuation z value on the top. Okay. So this is what I mean. Okay. What I mean is this. If you pick this number, okay, you know that the number is 0.299. So read its z value, 0.299 here, and that is 0.8. Okay, and then add the one on the top, 4. So it becomes 0.84. 0.84. Fantastic. Okay, so now you're going to, that is a z value. Okay, that is a z value. So now you will write here that you're now going to document this information that the z, okay, for 0.3 is 0.84. 0.84. Now that you got in that 0.84, rewrite your z formula. So in your z formula, in case you've forgotten, z formula is z equals to x bar minus mu over the standard deviation. Now let's substitute the value. One important clue you should notice this. Everything was done on the left-hand side of the mean. And the moment you are doing everything on the left-hand side of the mean, whatever z value you get, you should make it a minus. Make it a negative sign. Whenever you are working on the right-hand side of the mean, whatever value you get should be positive. So knowing that, you got to know that now you didn't know, but now you know. Since we are working on the left-hand side of the mean, the z value here must be minus 0.84. So you write minus, let's go, you write, you're substituting. So you write minus, let me write it somewhere. Okay. So you get minus 0.84 equal to the mean, which we don't know, that's what we're looking for. The x bar, the x minus the mu, and we know the mu to be 8. Okay. So let's write the 8 there, divided by the standard deviation, which is 5. So now you're going to cross multiply the 5 by the negative 0.84. What do you get? And then you move the minus 8 to the left-hand side, and that will give you the value that you are actually looking for. Okay. That'll give you the value you're actually looking for. It's very, very simple. Everything, by the way, is in your notes. Okay, let me just show you here. So if you work it out, oops, if you work it out, you are going to get something like this. So this, I've just indicated everything here. So you have it here as this corresponds to, where is this? This corresponds to a z value of negative 0.84. And the reason why it's negative is because the direction is to the left of the mean. And when you substitute everything and work it out, you get 3.8 series. So when you go back to the table that you were trying to deal with, this is a table that I did. We were looking for a certain price where 20% of all prices are below this price. The price we are looking for, our calculation gave us 3.8 series. And truly, it makes sense to understand that 3.8 series is truly below 8. And that one that is in the, to the left of it. So the price that we are looking for is 3.8 series. So it means that 20% of the prices are all below 3.8 series. That's what it means in practice. Okay? That's what it means. So sometimes, and this price is the random variable that sometimes you become. So 20% of the values from the distribution with a mean of blah, blah, blah is less than 3.8. Now, let me ask you something. What if, I like those what if. What if I have said that, I want you to tell me a certain price where 40% of prices, 40% of all the prices are above this price. Okay, I want you to tell me the price where 40% of all the prices are above this price. How would you demonstrate the question mark? Where would you have placed this question mark, which I actually take here? Where would you have placed that question mark? Where would you have placed that question mark? Where 40% of the prices are above this price, which area would we be looking at? Where 40% of the prices are above this price. 40% of the prices are above this price. Okay. It will be to the right. That's good. Okay. So now, when it is to the right, which area are you looking for? So now you indicated that it's to the right. So this is to the right. Okay. And we are talking about 40% of the prices are above this price. Are we talking about, let me call this A and then B. Are we talking about area A or area B? Which area are we talking about? Is it area A or area B? A or B? Area A or B? 40% of the prices are above this price. 40% of the prices are above this price. Which area would you try? Area B. Okay, so that's going to be area B. So we're looking at this area. We want which price is here, to give us that. Now, to get this area, of course, we don't need to get this area because this area is 0.4 already. It's told us 40%. So if you want to get the answer to this price, you need to know this area before the 0.4, and that area is 0.1. Okay, so now you have to go and search for the 0.1 in the table. And when you search for the 0.1 in the table, get its corresponding z value. And remember that everything is to the right of the mean. So because it's to the right of the mean, the value will not be negative, but it will be positive. So whatever z value you get. So let's say we go to the table. You're going to look for 0.1 in the table. 0.1. Okay. And if you look at this carefully, 0.1 is somewhere here. Okay. 0.1. Okay, is between 0.0987 and then 0.1026. Okay, 0.1026. So the question is, which one of these is closest to 0.1? Which one of these is closest to 0.1? And like I always say, you take 0.1 and you subtract the first one from it. Sometimes when you subtract, you multiply it by 1,000. Okay, so we subtract 0.1026. We multiply that by 1,000, that will give you 2.6. Okay, so you get that to be 2.6 in that regard. So that was 2.6 when I multiplied it by 1,000. The other one is you do 0.1 minus 0.0987. 0.0987. 0.87. So that will give you, multiply by 1,000. Oh, I'm lost. Let me just do it again, okay? Because I was just not focusing. So you get 0.1 minus 0.0987. And whatever answer you get, you multiply by 1,000. That would be 1.3. So it just shows you that this one here is closer to 1 than the other one. So 0.0983 is closest. 0.0983 is closest. So 0.0983 is what? If you check the z value is 0.2 and 5. So 0.25 is the answer. Okay, 0.25. So it means that this value here is going to give you a z value of 0.25. And once you get that value of 0.25, you can now use it to find the x by change of subject. And that will give you the price at which 40% of the prices are above. Okay, now I use the word 40% of the prices above. So that's how come you were able to get to shade this section. What if I had said 70% of the prices? 70% of prices. I want you to tell me a price, okay? A price where 70% of the prices are below this price. Okay. Let me rewrite this whole thing. I want you to tell me a price. This is 8, by the way, and then 5. I want you to tell me a price where 70% of the prices are below this price. Of course, I couldn't say, okay, are below this price. 70% of the prices are below this price. 70% of the prices will not be this 50%. So if it is going to be 70%, then we are talking about from here, okay, all the way, from here, all the way up to somewhere there. So we are talking about somewhere here. So that the whole of this to that is going to be the 70% of the price. You have to exceed. So that means that we are talking about a portion after the 50%. And that portion after the 50% is a 20% here. Good. So 20% now is a focus. Okay, because that's what the 50% we know is on the left side. So 20% is the focus. So you have to go and read the 20%. Go read this 20%. It's already there. So go and read, this is 0.2. You go and read this 0.2. Okay. And when you read this 0.2, go to your table, you look for the z value corresponding to 0.2. And when you check it quick, okay, you see that this is it. This is these two numbers, and it's closer to 1985. Okay, the number is 19.1985. Its z value is 0.5, and its upper value is 2. So it's 0.52. Okay, the corresponding z is 0.52. So now, and it is, if you look at it here, it is positive. So it's going to be 0.52 equal to the x you don't know minus the 8 over the 5. And then whatever value you get, that value that you get should be greater than, what do you call it? So you take the value 5 times, you multiply 5 by 0.52. Okay, so that will be 6. That will be 2.6 here. Okay, equal to x minus 8. When you move this one to this side, it means that you're going to get x equal to 10.6. So you can see that clearly that value is bigger than the mean. Okay, so the value, the price that we are looking for now is a 10.6, which is truly bigger than the mean. So that is it. This means that 70% of the prices, okay, are below this 10.6. That is what it means. See this. So there are several, ways of handling this thing, and you want to be able to look at them very, very well. I've just given you quite a number of them. This is another one which you have in the slide. It got nothing to do with what I've done. It's a practical application of normal distribution. I've done it in the slides for you. Check it, look at it. And then there are even some more questions, attempt questions that I've given you make sure you attempt all of them, and then you are able to master every one of them. Okay, just several of them. Because I like the situation where you're able to work so many of them and be able to get it. Ladies and gentlemen, that brings us to the end of the entire Kabuda. What a way to end probability.